Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. Project managers usually like innovation until it brings extra risk, extra meetings, and extra uncertainty. And printed electronics can trigger exactly that reaction, especially if your team has built its experience around classic PCBs and standard components. So let's walk through the 5 most common concerns PMs have about printed electronics and how to solve them in a practical, low-risk way. The first concern is simple. We don't have the know-how. Printed electronics is different from PCBs, so it's normal to feel that your team is missing experience, but you don't need to hire new experts or rebuild your organization. What you need is a faster learning curve. The best way is to work with a supplier who can provide workshops, material libraries, and clear checklists that translate the technology into decisions you can manage. Even more important, application engineers from a good supplier can support your team early because their experience saves time and prevents the classic mistakes that show up later as delays or redesigns. In short, you can learn fast if you learn with the right partner from day one. The second concern is, we don't know how to test it. Printed electronics often needs different validation than standard PCB assemblies. Instead of only electrical tests, you may need to consider bending, moisture resistance, UV exposure, and real-life mechanical stress. At first, that can sound complicated, but the good news is that testing can be structured and predictable. If your supplier has lab capabilities and experience, they can support you already at the prototype stage, not after the product is locked. In many projects, you can even develop custom tests together, tailored to your environment and use case. The key is to treat testing as part of the design process, not as a final go or no-go step. The third concern is, it's too expensive. Yes, some materials, especially silver-based conductive inks, can look costly if you compare only the raw material price. But project managers know that unit price is rarely the full story. Printed electronics can reduce total cost by replacing multiple parts with one integrated printed layer, which means fewer components, less assembly work, and fewer failure points. You also often save on tooling, molds, and mechanical complexity, which is especially valuable for prototypes and small batches. In many cases, printed electronics is not the expensive option. It's the option that reduces total cost when you look at the full system, not only the bill of materials. The fourth concern is, we don't have time to experiment. Deadlines make new technology feel risky because no PM wants surprises in the final weeks. But with the right approach, printed electronics can actually speed things up. With ready materials and fast prototyping, you can test a concept quickly, sometimes within 7 days, and then iterate fast while the cost of changes is still low. Quick iteration is not chaos. It's risk management. It helps you avoid big errors later, when the project is already expensive and hard to change. Close teamwork with your supplier, clear requirements, and fast feedback loops can turn experimenting into a controlled process that protects your timeline. The fifth concern is, we don't know if it's reliable. This is the big one, because reliability is what makes or breaks adoption. People worry about printed paths cracking, inks aging, or performance dropping in harsh environments. The reality is that modern inks and materials are much stronger than many teams assume. Reliability depends on smart material selection and good testing, and that's exactly why early collaboration matters. With proper validation, printed electronics can meet requirements linked to RoHS, ISO, and other standards, and printed parts can survive repeated bending cycles without failing. Reliability isn't a gamble. It's a result of design choices, material knowledge, and testing discipline. So the real message is this: printed electronics doesn't have to be risky. With the right support, it can save time, lower total cost, simplify assembly, and speed up delivery. The difference between fear and advantage is not the technology itself. It's the way you manage it and the partner you choose to work with from start to finish. If you want to take a practical next step, start with a simple question. Are you trying to reduce the number of components, make assembly easier, or launch faster? Then use a project manager checklist to evaluate whether printed electronics fits your project. And if you want a no-pressure way to explore it, book a short call with an LC electronic engineer. Not a sales pitch, just a technical conversation. Finally, look at a case study and see how other teams used printed electronics in areas like mobility or medical technology, because real examples make decisions easier than theory ever will. Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. Thanks for listening. If you'd like to see how flexible electronics can transform your product, reach out at lcelectronic.com.